everybody. How we all doing? Good. All right, so not only are we automating AWS with Python, but we're doing it for the most important reason ever, which is cats. So I'm going to just very quickly, if you were at IndyPy and you got to see this, we're just going to go over very quickly what my little project is. Today we're going to focus on recognition and on DynamoDB, and we're going to look at those two aspects of this, but here is what I did. So the Master Control Program, that's what MCP stands for. My Master Control Program, yeah, some of you Tron people caught that reference. I had a CentOS 7 box with Python 3.6 at home. By the way, when I show you stuff today, it could very well be running from my bunker at home because I'm hooked up to my VPN back to home base. So from there, I have a Python script that reaches out to AWS. We connect programmatically to AWS, and you see that little key there. That key is for IAM, Identity and Access Management. It spins up an EC2 server. That's what this little guy, I guess I could use my mouse a little. That's what this little guy right here is. So once the EC2 server is spun up, I have Python transfer files to S3. Now I'm doing it the old-fashioned way where I'm literally just copying to S3 and then copying to the EC2. If I were going to do it right and I had a little more time on this project, I'd use Git. And I would have it set up so that we could just spin up the EC2 and pull the files straight from Git down to the EC2, which would make it very easy to update because you could update your code, and every time you run it, you're going to pull the newest stuff. So then once we do that, you see this is S3 over here, so it's talking to S3, and we're also talking to DynamoDB. DynamoDB, if you don't know what that is AWS's kind of version of MongoDB. It's a NoSQL database. It is actually pretty cheap, by the way. We'll explain why I believe it's cheap later on, because it's a pain to use. But we'll get to there. And then this little guy right here, you may not recognize this symbol, but this is the symbol for recognition. So here is what the whole thing does. This EC2 reaches out to Reddit. It specifically reaches out to the cat subreddit, and it rips pictures. So it reaches out to the cat subreddit, it grabs cat pictures from it, then what it does is it pulls the cat picture over to the EC2. Once the cat picture hits EC2, then it makes a call to recognition, which we'll look at here in a minute. Recognition comes back and says whether there, one, is no people. We don't want people in the picture, because like we said last time, having people in the picture is creepy, because I don't know who they are. So if there's people in the picture, it gets tossed. What we do want in the picture is cats. So if it has a rating that's high enough that there's a cat, it's the image, then it stores the image in S3 because you never know when you're going to need more cat pictures. And then it also posts the cat picture to my cat Twitter, which we'll pull up right here. So I've got this cat Twitter, and since we've been standing here talking, it has tweeted, there's 47 seconds ago. There's 6 minutes ago. There's a cat in the sunlight a few minutes ago. So there you go. So about every 5 minutes right now, it is sending a tweet. Now, it's not perfect. I found this one earlier today. That is obviously not a cat. But for some reason, Recognition thought that it was a cat, and we'll talk about that in just a second too. I'm not exactly sure why, but I will say I've ran this thing a lot. Probably about 1,000 tweets at this point, maybe not quite that many. But the point is that this is the first dog I've seen out of all of it. I've seen a few hands, I've seen some bodies, like where people are holding the cat, but it's done a pretty good job of not having anything but cats. All right, so we're going to go to the AWS Console. That must be on my other, oh no. Well, we're going to open it then. So let's open the console because we need to go to AWS and look at some things. Oh, good, it's still there. Okay, so the first thing we're going to do is we're going to go over here to DynamoDB. And we're just going to see how things look. All right, so when you get to DynamoDB here, you see you have a provisioned read-write capacity. So what you have to understand, if you're going to use DynamoDB, it's pretty much free. I've been using it for this project. I've done tons and tons of read writes to DynamoDB, and I haven't gotten charged 1 cent yet for it. I believe it's 1 million read writes that you have to do in a month before you start getting charged for it, and it's like a whopping 50 cents or something. It's not that much. So it's really cheap. The problem is that it doesn't work very well for what I'm trying to do. So let's look at my tables here. There's the Reddit cats table, and we're going to look at the items. It's a little bit small. Can I make that bigger? There we go. So, not wanting to scroll. So there you go. Here are the items. All I have is, I did some epoch time for my index. I have just a couple little flags here. Has it been downloaded? Yes. Has it been stored to S3? Yes. The submission ID from Reddit. I really don't need that, but I was, again, trying to get some data. Has it been tweeted? Yes. And what was the actual URL? And actually, to be honest, the only reason I even have that submission URL or saved it was because I've had some issues with it erroring, and I don't know why. Every once in a while, it'll error, and it says there's a colon on the front of the HTTPS. And I have no idea, in God's green earth, where the colon is coming from when it errors. I've tried all kinds of stuff to catch it. I tried to run substring, like find and like remove and all that, replace, like string magic. I don't know where it's coming from. It's weird. So if any of you know why that would happen, let me know. Let's see here. It's going to make a liar out of me because all these look pretty good. Oh, there we go. Okay, so for instance, there's no submission URL on this. And because of that, it doesn't quite work right. Look, it's never been tweeted because it couldn't find it, so it couldn't do its job. Let's see if there's any more. Here's some other ones that just say ready. Oh, those are the ones that probably are ready. Has it been tweeted? Nope. So here's what I did. I guess I've been able to fix it better than I thought. What I had to do, though, is I had to, every time I make a call to DynamoDB, I've had to, let's go to some code here. I've had to put in like some 5-second sleep. So let's Command F, let's do sleep. There we go. So what I've had to do is when it does a write, that's sleepy time. That's a great function right there. Everybody needs a sleepy time function. So here we go. So here we go. I have dyna.delete item, mention the table. Can you guys see that at all? Is it way too small? So I want to delete the item, and then I sleep. And what I found is that if I make the call to DynamoDB and I sleep, then it works, and it's happy. But if you thrash that DynamoDB API, it acts like it can't write. And it goes back to this read-write. So if you want that kind of performance out of it, you got to pay for it. So AWS will give you that kind of performance where you can slam that thing. But if you're going to do that, you're going to be paying a lot more for it. So that's what I came to figure out, is that it's not the read-writes that they're going to get you with. It is how often are you hitting it and how fast are you hitting it. So that's what you're actually paying for. Someone asked me when we did this for IndyPy, why didn't you use, like SQLite or something like that? And I said, because that wasn't the project. The project was to try to use AWS. But if I were going to do this for real, I would use SQLite, and I would probably set up a little SQLite inside that EC2 and just let it do its thing. Because really, in reality, once it dies, I don't care anymore. I don't really need that data. You have a question?
Yeah, I do, actually. Could you not use events on the DynamoDB table so that as new ones come in, you could actually get an event when it's been saved?
So say that one more time.
Use DynamoDB events, like a CloudTrail event, to then have a Lambda to kick off the subsequent follow-on process. So you can make it a little more asynchronous. So you don't care how long it takes for Dynamo to write at that point, as long as it's asynchronous.
Exactly. And if you were, and you're right, if you were going to do this for real, you would need something like that. For this, I don't really care, but you're absolutely right. Well, yeah, I know the cats are important, and we have to do our best to try to help them. So. So any questions about DynamoDB real quick before we, okay. Other than that, let me go back here and let me also show you this. So what I ended up doing too was, see, I have this DynamoDB Wrapper functions, and Again, I've got this on GitHub. I stole it. You can steal it from me. I found this really nice blog post out there that had these wrappers, but they were all loose. So the blog post had a bunch of loose functions, and I took all the loose functions and made it into an actual class. So I created this little wrapper class. You see here I've got a create table. No one wants to do all this. See all this junk in here with all this JSON and all that? Nobody wants to do that. So you make a nice little wrapper and just put your parameters in and be done with it. Same thing down here. I've got a set table name. Get the table metadata in case you need it. Read the table. Add an item. Delete an item. Scan. When you're doing a query, DynamoDB calls it a scan. So you scan DynamoDB for whatever information you want. You get an index. So you get one primary index. And then if you pay for it, I think you have to pay for it, you get a secondary index. And that's it. And it can be very slow trying to scan DynamoDB if you don't set up your indexes right. I've actually thought a couple times of rebuilding this. I haven't done it. But you really have to think about, what do I actually want to be my index? Because if you pick the wrong thing, you're going to have to rebuild it, and it's going to be really slow. Does that make sense? Okay. So I would highly recommend, like I said, going and either stealing my wrappers or my wrappers aren't the best, they work, or stealing somebody else's, because, like I said, trying to directly deal with DynamoDB was a pain. A lot of JSON, a lot of stuff that just with a little bit of, a function, you're good to go. All right, so let's switch over to some of the other fun stuff. So recognition. Let's find that real quick. There it is. There's nothing super glamorous to show you as far as trying to make a recognition call. If you've never tried to hook to AWS and use recognition, I'm here to tell you it is easy. It's super easy. That's it. That's my function for recognition right there. I mean, you can find all kinds of blog posts about it. You can go out and find this code anywhere. So all you do is you send the picture to AWS, and AWS sends you back JSON. That's all there is to it. It's that simple. Now, it's pricey. Like I said, DynamoDB was cheap. I started the cat Twitter back up last night when I was getting ready for today, because I thought, okay, I need to start it back up, make sure everything's running right. And when I haven't checked it today, but I know when I ran it a couple weeks ago for, I think, about 16 hours, I was up to $3.50, $5, somewhere in there. So it can get pricey quick. If you were going to run this recognition all day long, every day, I'd be spending $10 a day or something on it. I don't want to do that. I love the cats, but I don't want to do that. So since this part isn't fun, let's look at the part that is fun. So I set up Splunk. Oh man, we are definitely going to have to make that bigger. Okay. So in the logging, and I talked more about this in the first talk. I didn't know this about logging until I did this. I'm used to logging to a file. You log to a file all the time, right? You don't want to use the print statement. You want to log to a file so that you can go back and see what your program has been doing. Well, what I discovered, and I don't know why I never knew this, is that you can log to more than one place. I'd never thought about it before. So I added, not only does this thing log to a file, it also sends the log information to Splunk. And if you don't know what Splunk is a data analytics tool. A lot of companies just use it for log files. They put all the log files from their systems into it, and they can watch it and have monitoring and alerting and things like that. A lot of companies use it for security because it's going to watch for different warning signs and alert on that. But it's also very good for something like Python running on a remote system, and I have it sending these logs back over HTTP back to home. So I could have a distributed system going on, and all the logs from my distributed system could all be coming back to one place. It makes it easy to troubleshoot my program and my code if I'm doing that. So with that in mind, let's look here. So here is, you see my log has this very, if I get my, there we go. So my log, I tried to make it descriptive here. Here is the recognition data from temp image, blah, blah, blah. So you'll see here, this is what you get back. You get this giant mess of JSON back, and it says things like, here it is, name, cat, confidence, 94%. So it's pretty confident that there is a cat in this picture, and that, of course, is why it's here. But it gets really funny as you keep looking at more of it, because let's see what else it thinks it found. Snow. There we go. It has a 57% chance that there's some snow in the picture. It thinks there might be a leash in the picture. It thinks there might be a dog in the picture. It thinks it might be a husky. I love that. It tries to go even what breed it thinks it is. A 48% chance that that is a husky. Let's look down here. Countryside. It even lets you know like where the setting is. So it thinks it's in the countryside. I'm not sure how it defines that. Yeah, it seems kind of arbitrary to me. But anyway, bird. Clothing. So what I had to do is I had to basically make some calls. So I've got to take this JSON. If I can go back and let's see if we can actually find it and see what I did. I'm kind of scared to show you, to be honest, because it's probably an ugly way of checking. The point is that what I have it doing, oh, here we go. So all I have it doing is, look at here, if stuff name equals person or stuff name equals human. I don't know what the difference between a person or a human is, but recognition makes the difference. There can be persons and there can be humans. We've kind of theorized that maybe one is more of a picture, like maybe a painting or like a stick figure. I don't know if a stick figure is a person and Calvin is a human. I don't know. But I had to do both, because if I didn't do both, some would slip through. So there it is, and I had to basically search through those keys. That was what I had to do. And then down here, we have to make sure there is no person, and then we make sure there is a cat. And if there is a cat, then it will run through and do all the other bits that it needs to do to send the cat to Twitter. Let me expand on this a little bit, because people always, when they talk about recognition, they want to go to like facial recognition and stuff like that. So let me explain the difference between what I'm doing and like facial recognition. So what I'm doing here is I'm getting objects. You make a call to recognition, and if we look at it here, let's see what the exact, because I'm recognition client, see what path what command we're actually calling here. There it is, detect labels. That's what this one is, okay? So detect labels is what I'm doing, and what that does is it looks for all the items in the picture. So that will tell you what is in the picture, not who is in the picture. So all this does is return back a bunch of JSON. If you look for facial recognition, when you do the facial recognition function, you have to create a database in AWS if you want to save the signatures of the person. And this is interesting to think about. I hadn't thought about it until I actually played with this. I've played with this a little bit. So pictures in of a person or people, and then you have to create a little database in AWS where it will store the signatures of those faces. Now, remember, when we did this, the detect labels, we sent it the picture, and we got JSON back saying, here's what I found, here's what I found. All it does in AWS, with facial recognition, is it comes back and says, here's the signature that we found, like a big number. That's it. It doesn't tell you how it did it. It doesn't tell you what the significant points were. You can't reverse engineer it. You can't even really keep it locally, at least as far as I know. That's their database. So if you wanted to create a facial recognition database, they're basically keeping you in a closed system. You have to continue to use recognition, and you have to continue over time to build up the database inside of AWS. And they charge you for however many faces you get. So the more faces you're storing, the more they're going to charge you each month to keep that facial recognition database there. So that's a big difference. I know when we've talked with law enforcement, because we've had some law enforcement clients that have asked about these kind of capabilities, and we've had to explain to them that, look, sure, if you want to use AWS for your facial recognition, that's fine, but you have to understand you're not keeping a local database of this. It's not how it works. You don't ask AWS to identify and then get the signature back. Not really. You really have to store it up there in the cloud and keep it with them, which some people, that's a red flag.
So does recognition allow you to train it with custom images and labels, or are you relying strictly on their pre-trained databases?
I have not tried to do that yet. I am not sure if they have that capability or not. That would be interesting, though. It would be cool if you could do that, but I don't know. All right. Now, the faces, yes, Calvin, you can't, I do know that. Now that you mentioned that, I remember you can send it several pictures of one particular face and tell it this is this face, and help it train on a particular face, if that makes sense. All right. How much time do I have left, Calvin? Okay. Okay, good. So let's talk about, since I have a little time left, let's talk about one more piece that I felt was really important from this project that I learned that I think other people might enjoy learning. So if we start from this slide, maybe, nope. Oh man, now I lost everything. There it goes. Okay, we'll just leave it like that. So one of the things that you always worry about when you're trying to set up a system like this and you're trying to integrate things like Python and you're trying to automate the standing up of a machine out in the cloud is how do I get credentials to that machine and how do I pass things? Because if you remember, I am using, I'm doing Reddit and I'm doing Twitter, and both of those I've got to have my keys because I create an app with them. And so you get the secret key and your consumer key, and you have to use that when you hit the API so they know who you are. So they know who to shut off when you hit it way too many times in 30 minutes, right? So how do you pass that information up without exposing it to the world? So that was something that I had to really kind of think through. And here's what I came up with. You might be able to come up with something better, but here's what I came up with. So in my script, I used config parser and have a config.txt. So the only place on my local machine at home where I'm storing these in plain text is in that config text, and that's inside my home network on my machine at home. When I start the program, the Python script will read from config.txt, and it will read in all those variables that I need. The consumer key, the secret key for Reddit, and for Twitter. And I think there was some, and it also reads in the token for my Splunk, because Splunk has to have a token as well to be able to send the data back to Splunk so that it's verified. So then what I do is at that point, I make this giant, let's go back here and look at it, because it's cool. I have to make a giant bash command out of it, basically. This is in the mcp.py. So I take in here they all are. Config parser reads the config file and reads in all these different variables that I have. See there, I've got access tokens and consumer keys. I got the DynamoDB name, whole bunch of junk. And then right here, EC2 Startup Script. So what they allow you to do is they allow you to pass in some bash when the EC2 starts up. Now, if I were going to do this professionally, I wouldn't do this. I personally would probably use Puppet. And I would have Puppet do this bash part of it for me, because all I would have to do then is just install Puppet and then pull the files down and let Puppet do it all, and I would feel much more confident than trying to run this giant bash. But here we go. So here's the bash. Now look at what we're doing here. A lot of it, we're installing Python 3. Also, good thing to know, the Amazon Linux image has Python 3.6 in its repo. You don't have to add any repos or anything. Like, it's just right there. It makes it very easy to get Python 3 running immediately on that Linux AMI, which I was really happy. At first, I was going to go with a CentOS machine up in AWS too, but I was having real issues trying to figure out how to get Python 3.6 on it. I mean, I could have done it, but it was so easy over here It's like, forget it, I'll just use this. Then, what I ended up doing was I ended up saving all of these variables, all those variables that I had, I put them into an environmental variable on the Linux machine up in AWS. So again, I'm still not storing it anywhere in an actual file. It's only living in an environmental variable in the machine. One of the things that you could do, and I did not do it this time, but you could do is you could make the machine basically inaccessible. So if you've used AWS, you know that you've got to use that PIM file to be able to, authenticate up. You're not using a password. You're using a SSH key. So if you either just don't have a key or you don't specify a key, there are ways of basically making that EC2 box completely inaccessible to anybody. And it's completely just a black box that can just be thrown away and spun back up, which is super cool. And then on top of that, you're hiding these things in environmental variables, so they're never going in the code. They're never getting written anywhere on a disk, other than the fact that they're in the environmental variable, but they're hidden away. So that was what I came up with. Then once that goes, you can see here, then I copy from S3, I copy the code in. Again, that's where you would want to do git instead of doing it like I did. And then cron tab. So the way that I make sure that my program keeps running is I have cron trying to run the program. Every 5 minutes it checks to see if the programs are running. And basically inside the script, starts a new instance of the script checks to see if it's already running. So as soon as it starts up, it says, is there a copy of me? Oh, there's a copy of me running already, and it just destroys itself and goes away. Okay, so that was how I did that part of it. Let's see here. If you want to create an EC2 instance in the cloud using Python, the super cool thing also is that you can have all kinds of parameters you pass to it. So you can see here the image ID. Now the image ID here is, we went back up to the variables. I'm just telling it to use that Amazon Linux AMI. That's all that's pointing to. You can point it to whatever image that you have up there. If you make a, that's another thing you can do. So let's say you spin up an EC2 and you modify it. You put your code on it, you do a bunch of stuff to it, you add things on it, and then you make an image of that machine. Theoretically, just call that image every time, and it's already pre-set up. I could have done that with several of the things that I did. So I've got the Python 3, and I'm installing that every time. I could have spun up an image, added Python 3, done all the things, made an image of that machine, and then always just pulled from that image and not have to go through all of the process of installing everything. Does that make sense? So there are different ways of handling it. You have a max count and a min count, so if you want to deploy a fleet of servers at once from your Python, you can. If you want to, spin up, 50 servers at once for an hour and see how fast your bill will go up, it's very easy. Just change this number from 1 to 50 and watch the dollar signs fly. Instance type. Key name, let's see, this user data right here. That is that crazy bash script from up at the top. That's where you put it in at. I had to search Stack Overflow and a bunch of places and the Boto3 documentation to figure that out. You would think more people would want to know, how do I pass a bash script and get it going? But it was not easy to find that. And someone asked a very good question last time. They said, why is it called user data? And I said, I don't know. Why isn't it called startup script? Why isn't it called initial instructions? Anything other than user data, that sounds like my account info. That doesn't sound like what I'm going to start up my EC2 with. So I don't know why they named it that. It's weird, in my opinion. You can assign subnets, groups, associate a public IP address. Now, in this case, I have true, because I need to be getting in and troubleshooting the machine if it dies. So when I was trying to develop it, obviously I'm going to want to be able to SSH in and figure out why it broke. Why am I not getting any more cats? I haven't had a cat in a half hour. Something's wrong. So I can SSH in. But if you get the system to where you feel like it's running correctly, turn that off. No public IP address, only a private IP address. And then you're even more secure because now it's inside a closed subnet in AWS. It's only making network calls out So the returns will be allowed in, but nothing can actually come into it. So you're safe, theoretically. Role. So I have a role for the machine. The machine has access to S3, and the machine has access to DynamoDB. So you have to set that role inside of here. But again, that's super cool because you can spin up the machine and give it a role right on the initial spin up. Down here, this is just, I want to say like stupid hard. That is how you give the instance a name. That thing. Why is there not a tag that's just name, like machine name? I don't know. They make you put that much JSON on there just to give the machine a name. I don't know. AWS, you're so funny. All right, so then I got my logger stuff here. Let's see if there's anything else I need. For my own benefit, I added in this EC2 info. So when you spin up the machine, you don't necessarily get a ton of feedback back from AWS. You actually have to query back and say, hey, I need more info. So what I basically did is I wrote a little function that after it spins up, it will reach out and say, hey, can you please now tell me what's the ID number that you gave the machine? What's the public IP address you gave it? Because I'm going to want to know those things. I'm going to want to log into it. So I have it log back out to me as soon as those things pop up and as soon as they're available. There's other fun things here. You see like there's even a launch time, different things like that. All right, I'm going to go ahead and open up to questions at this point. So sorry if I kind of jumped around a little bit, but what questions do you have about this whole setup?
Yeah, if anybody's got questions for Josh, I'll bring you the microphone so we can get it on the recorded. This is recorded, so if you actually want to catch up and watch it again, it'll be on YouTube. Probably later today.
Awesome.
Could you elaborate a little bit more on how you tied Splunk in to those events? Yeah.
So there's a really nice module out there that's actually being updated. Really happy about that. Some very wonderful person out there is keeping this up to date. And you see here from Splunk handler import Splunk. So that's the name of the module is this Splunk handler. And then down here, let's see where I've got it at. Somewhere in here, I've got Splunk log info. So again, I have all the variables are actually in that config parse text file, but here's all you have to have. You got to have your host, you got to have your port, you got to have your token. This uses HEC. HEC is the HTTP event collector. So what that means is that you are sending the bits of information over HTTP to Splunk, and you have a token, and because you are sending the token with the data, when Splunk gets it, it says, oh, yep, that's mine, and it takes it in. So that's how it's able to receive it. So you just have to have the token set up. And again, the super cool thing, I don't know how it does this either. It's just magic. I love it. But it will tell me, when I go into Splunk, Splunk actually tells me which script this came from. Let's see if we can find it down here at the bottom. Man, that's long. There it is. So there it is. It's coming from the ripreddit.py. So you even know what script this event is from immediately. So again, if you had a distributed system set up and you had 10, 15, 50, different endpoints that are sending data back to this Splunk instance, you're going to know, especially if you name it in a way that makes sense to you, you'll be able to start really checking out all this data. And of course, you get to tag the event. I mean, you're creating the event you're sending back. So whatever specific tag you want to throw in every time you send an event back, that'll make it easier for you to find it. So did that make sense? That's really all there is to it. I mean, there's not any more. Once you do that, let me go. I guess I'm going to go to logging here. So here was what I was talking about. So there's your standard, self.logger.add handler. That's your normal logging command that's going to let you log to a file. And then all I did was just add a second handler, Splunk. So it goes in both directions at once. And again, I don't know why I never thought about it, but it's pretty cool to just have it go to both places at the same time.